Hi, I'm Hans Mittelbauer, head of the Development Aid Group Solar Cookers of the State Vocational School Altötting. Today I'd like to present to you our school project, Solar Cooker. Since the beginning of the 1970s, our school has been involved in development aid projects in Peru, Tanzania and Togo. Because of this work, we became aware of a particular problem, namely the firewood crisis. Where there was once impenetrable primeval forest, desert is now spreading. Current research has provided evidence that the combustion efficiency of a three-stone fire is only 8%. On top of this, smoke from wood or charcoal fires is a health risk. Cooking actually kills more people than malaria. Open fires can lead to terrible burns. So this is our alternative: use the sun for cooking. Our solar cookers are so-called parabol solar cookers. Rays of sunlight which hit the reflective parabolic surface are redirected and concentrated into a focal spot, where temperatures reach more than 300 degrees centigrade. Every 15 to 20 minutes, the parabolic mirror needs to be adjusted to the position of the sun. To be able to do this, we fitted a position marker on the side of the parabolic dish. By turning and swiveling the dish, you make the shadow of the position marker disappear, as you can see in the picture on the bottom right. The possible applications of the solar cooker are quite varied. It can be used for cooking, baking, frying, preserving, but also for boiling up water to obtain safe drinking water and for sterilizing medicinal materials and equipment. It's also possible to make juice, as you can see on this slide, or even roast coffee. It's also possible to dye wool or fabrics. As I said before, possible applications are varied, and I'm sure you can think of many more possible uses. We offer support to interested partners for the on-site production of solar cookers. This is a workshop at SAPOP in Fimela in Senegal. Before the pandemic struck, we were offering monthly one-week construction courses in Altötting in Germany for participants from all over the world. Apart from assembling a cooker, we also teach how to properly use the cooker and also how to care for it. Another important topic we talk about is concepts for introducing the cookers and potential problems with acceptance. Of course, our senior experts demonstrate at your location how you can construct a solar cooker yourself. You only need a few tools to build a cooker in local workshops without machines and electricity. Some of the tools you will need are leverage shears, a duplex notcher, an angle bender, and a round bender. Because angle benders and round benders are expensive pieces of equipment to buy, we decided to involve the students of our metal department in developing and manufacturing them as part of a practical and theme-based course. Here you can see the construction drawings. And on this slide, there is one of our students carrying out one of the production steps. Of course, you can only use our solar cookers on days with direct sunlight. To save firewood on cloudy or rainy days, we've developed efficient and powerful firewood-saving cookers. Using these cookers, you can save more than 70% of firewood compared to a three-stone fire, and cooking is more or less smoke-free. So how does a firewood-saving cooker work? Fresh air supply comes via the opening in the cooker and the ventilation duct with grid, shown by the blue arrows in the slide. Cold air rises between cooker shell and combustion chamber. It's heated and the rising wood gas is completely burnt. This is the principle of a wood gasification boiler. The air supply pipe, which you can see in the center of the diagram, channels the flames and ensures the correct distance to the cooking pot. A curved metal sheet works as a kind of efficient chimney, and it ensures that the flames spread over a large area of the cooking pot. On the curved sheet of metal, forming a kind of efficient chimney, you can use a bracket to adjust the cooker to fit the size of the cooking pot. On this slide, you can see one of our experts building a firewood-saving cooker on location in Uganda in 2012. These two photos show some of our students building a prototype. Here we are in Senegal, where we're presenting our cookers. And following the presentation, we can see one being used. Apart from the firewood-saving cookers we've seen just now, we also offer a clay cooker. For making a clay cooker, you need a mixture of clay, sand, and a little cement. This mixture is pressed into molds. Then the molded parts are air-dried and the firing happens while the cooker's in use. Particularly in rural areas, electricity supply is often very unreliable. We've developed a do-it-yourself solar lamp. Here you can see the materials and parts you need for building a solar lamp, following our set of instructions. This self-made solar charger can be used to charge smartphones and tablets. The next few slides show some impressions from a refugee camp in Tanzania, Nyarugusu, which is close to the border to Burundi. We delivered a number of solar cookers for the camp. According to the United Nations High Commissioner for Refugees, about 150,000 people live in this camp, which was originally built for 50,000 refugees. Klaus Strasser, a member of our association, worked in the camp for a year and introduced the solar cookers to the camp. First, the cookers were presented to individual persons of responsibility, who actively helped in assembling the cookers. This was followed by a demonstration to the residents of the camp. During the course of the project, 4 prototype solar cookers by EG Solar were tested by 4 families in the refugee camp. Following successful testing, the United Nations High Commissioner for Refugees approved funds for a solar cooker pilot project. The EG Solar Association was able to send 150 kits of nano-ceramic-coated reflector sheets to Tanzania. These were used on location to build 100 solar cookers. 100 families were selected to put the cookers to the test for a period of 6 months. Now we come to another important topic. It's in relation to agriculture, and it involves water hyacinths. They are the fastest growing plants worldwide, and that's a problem. They're considered a superweed for a number of reasons. They deprive plants and fish of vital nutrients. They poison the atmosphere with methane gas, and they paralyze shipping. This slide shows the harbour at Kisumu on Lake Victoria in Kenya. If water hyacinths are not harvested, they become a climate threat. This is because the plants produce large amounts of methane gas when the dead plants rot underwater. However, the effect of methane gas on climate change is up to 25 times higher than carbon dioxide. So, is there a way to use water hyacinths in agriculture? Yes, there is. They can be turned into biochar. To do this, the plants first need to be harvested. Then they need to dry in the sun before they are carbonized. This is where the solar cooker comes in, using it for carbonizing. Another way to do this is using a C2C kiln. It only takes 20 minutes to produce biochar from dried water hyacinths. Biochar can be used to permanently improve soil fertility. It helps to retain water in the soil. It improves the structure and quality of the soil. It filters toxic substances from the soil. It stimulates plant growth, and it reduces pollutant methane gas and nitrous oxide emissions. Apart from all these benefits to agriculture, biochar can be used as fuel for our energy-saving cookers as a substitute for charcoal. So, thank you for listening to my presentation. If you now have any questions, I'm very happy to answer them.